We're now going to study the alkene homologous series. In this video, we're going to look at the functional group for the alkenes. We're going to look at the first three members of the alkene homologous series, their names, their formulas, their displayed formulas. We're going to have a look at the isomers of these compounds and their structures, and we're going to consider how the alkenes react. So to start with, we'll look at the functional group for the alkenes. So the alkenes are a series of unsaturated hydrocarbons. Unsaturated means that they contain carbon-carbon double bonds, at least one double bond within the molecule. Hydrocarbon also means that the compound only contains hydrogen and carbon atoms. An example of this is this molecule here. You can see the carbon-carbon double bond, and then there's a single bond and hydrogens all the way around the outside. So some examples of the alkene series. So the smallest alkene is ethene, 2 carbons. It's not possible to have a 1 carbon alkene because you can't get a double bond between carbon atoms if you only have one bond, or if you only have one carbon. So ethene is the smallest member of the series with the formula C2H4. Propene, prop being 3, has 3 carbons and 6 hydrogens. Butene has 4 carbons and 8 hydrogens, and you can see in this structure here, it's not properly a displayed formula because I haven't shown the bonds between the carbon and the hydrogens in these carbons, but butene C4H8. You'll notice that the general formula for the alkenes is CnH2n. So for every number of carbons, you have twice that number of hydrogens. You'll also notice that when we name the alkenes, all of their names end in ene, E-N-E, which indicates that it is an alkene. So looking at the isomers of the alkenes, so first of all, the only isomer that we can look at is of the formula C4H8, and there are 3 isomers that we're going to look at. So there's this one where the double bond is between the first 2 carbon atoms, this one where the double bond is between the middle 2 carbon atoms. So this first one would properly have the name but1ene. The second one has the name but2ene. And then we get a branched chain isomer where we have 3 carbons in a chain with 1 carbon coming off the central carbon and double bond between 2 of the carbons. And this isomer would be called methyl propene. Methyl because there's a 1 carbon as a branch, and propene because there are 3 carbons in the chain. So looking at the reactions of the alkenes, the first thing is that they all do the same reactions as the alkanes. So they undergo combustion. As we can see in this video, we've got some ethene in a test tube, and that ethene burns with a yellow flame. It will undergo cracking as long as there are enough carbons in the chain, and they'll undergo a very, very slow substitution reaction with halogens in the presence of UV light. So that's the same as the alkanes. However, the alkenes also undergo some more reactions, and the reason why they undergo these reactions is because that carbon-carbon double bond makes the molecule more reactive. So the first thing that they do is that they undergo addition reactions with halogens. So the alkanes undergo substitution reactions where the halogen takes the place of the hydrogen. In this case, the alkenes undergo addition reactions where a halogen will add onto the alkene molecule, and it will add over the double bond by breaking the double bond. This reaction is a very fast reaction, and it can be used as a test for unsaturation. As we can see here, we've got a test tube with ethene in it. We add some bromine water, which has that orange colour. We give that a shake, and what we can see here is that the colour has disappeared. It's become colourless. So there's a colour change there from orange to colourless. So looking at the equation for this reaction, we have ethene, C2H4, with that double bond, reacting with bromine, Br2, and the bromine has caused the double bond to break, and we've got one bromine added on either side of the double bond, and we've now produced a compound which is a halogenoalkane. It's an alkane because it has a single bond between the carbon atoms. It's no longer unsaturated. This is called a dibromoalkane. Specifically, this would be called 1,2-dibromoethane. And notice how the name now ends in ane because the molecule is saturated. Bromine has an orange colour when it's dissolved in water. The 1,2-dibromoethane is colourless, which is why we have the colour change in the reaction going from orange to colourless. So this is a really handy test for unsaturation. The second reaction that alkenes can undergo is with other alkene molecules. And this reaction is called an addition polymerization. Again, it's an addition reaction because the molecules just join onto themselves. We only make one product. Polymerization means that we join many alkene molecules together to make a polymer. Now, polymers are plastics, so this reaction is incredibly useful for making plastics. The individual alkene molecules are known as monomers, mono being one, so single molecules, and many of those monomers join together to make a polymer. I'll show you a brief video clip to illustrate this process. Okay, so this little model will represent what happens to an alkene when it undergoes addition polymerization. So we'll start with just one alkene molecule. This is ethene with 2 carbons and 4 hydrogens. And what we've got here are lots and lots and lots of ethene molecules. So we've got many ethenes. Each individual molecule is known as a monomer, mono being one. So we've got lots and lots of single molecules which are going to join together to make one large molecule called a polymer. Poly meaning many. So what happens is, to start the reaction, you need to add an initiator, and what the initiator does is it causes the double bond to break. And the double bond breaks, and this causes the molecule to attach to its neighbour, causing its neighbour's double bond to break, and they join together like that. And that then carries on going all the way along with all of the molecules.
Okay, so we've now produced one very, very long molecule with all of these monomers joined together. At the end of the molecule, we can see that the molecule can carry on joining onto more molecules if necessary. And just made one very, very big molecule.
Okay, so if we represent this reaction, and I'm only going to show 3 ethene monomers, these can join together, and these 3 monomers, so 6 carbons in total, will join together like this to form a longer chain. Notice how at the end of the molecule, at the end of the polymer, there are these bonds which aren't attached to anything. Really they'd be attached then to the next monomer. These bonds are called trailing bonds. And once we've made our huge molecule with thousands and thousands and thousands of monomers joined together, at the very end of the chain there would be the initiator, the chemical which started the reaction, but we don't need to show that. So this is a representation of the reaction using 3 ethene molecules. This happens huge numbers, so if we use the letter N to represent many molecules, thousands and thousands of molecules, what happens is we'd have N ethene molecules reacting to produce this unit repeating itself N times. And so we can represent our polymer using the structure of the monomer where the double bond has broken and the double bond then trails out either side of the molecule, going through that bracket, and then the polymer can be represented by that unit with the N, where that unit will repeat itself a very large number of times. So the first equation there, N would be 3, so we'd have 3 of this, and so we'd have this structure repeated 3 times. With a large number, we can use the letter N. Now, when we name our polymer, although the polymer is now saturated, it no longer has a double bond, the name of the polymer is taken from the monomer name. And all we do is stick the prefix poly in front of the monomer name. So we started here with ethene, and our polymer would be called polyethene. Polyethene is commonly known as polythene, which is a very common plastic which is used to produce plastic bags, plastic bottles, and things like that. Here we have our ethene again, called ethene, and that makes the polymer polyethene, like that. So some other polymers. So here we've got the monomer propene with 3 carbons. What I'd like you to do is just to pause the video and see if you can draw the structure of the polymer and give the polymer its name. Okay, so here's the structure of the polymer. What we've done is we've taken the double bond, we've broken the double bond, and the double bond now trails either side of the brackets. And we've got our structure of the propene with CH3, CH, CH2, like that, with an N outside the brackets. So that's our structure of the polymer, and the name of this polymer takes the name of the monomer, propene, and puts the prefix poly in front of it. So this would be called polypropene. Polypropene is another very useful polymer, useful plastic. Polypropene is used to make washing up bowls and crates and various sort of harder plastic objects like that. Okay, so here's another polymer. This time I'm showing you the structure of the polymer, and this polymer has the name polychloroethine. What I'd like you to do now is to pause the video and see if from the structure of this polymer you are able to draw the structure of the monomer and give the name of the monomer. Okay, so here goes. The monomer would look like this. It's C2H3Cl, and the name of this monomer is chloroethene. So it's an ethene molecule with a double bond between the carbons, but there's a chlorine atom attached to the molecule. It's no longer a hydrocarbon. It's a halogeno-alkene called chloroethene. Chloroethene has an old name. Its old name was vinyl chloride, and the polymer that we'd make from vinyl chloride would be polyvinyl chloride and would have the shortened version of the name PVC. And PVC is a plastic that's sometimes just called vinyl and is used for window frames, flooring, gutters, and things like that. Okay, so the final one that we're going to look at is tetrafluoroethene. Tetra is a prefix that means 4. Fluoro is the name we give to fluorine atoms in an organic molecule, and ethene, 2 carbons with a double bond. So tetrafluoroethene. What I'd like you to do is again to pause the video and to draw the structure of the polymer and give the name for the polymer. Okay, here it is. So the structure of the polymer, again, we've broken the double bond. The double bond trails either side of the molecule, and the trailing bonds go through the brackets, and we have an N outside the bracket. The name of this polymer is polytetrafluoroethene. Polytetrafluoroethene is commonly abbreviated to PTFE, and PTFE is sometimes sold as Teflon, which is a non-stick coating which you can have on frying pans and things like that. It's also the polymer in the Gore-Tex waterproof breathable membrane that you have in lots of outdoor clothing. In the notes I've shown you another example, which is polystyrene or polyphenylethene, as another common plastic which you'd be aware of. So those are all the monomers and polymers which you'd be expected to know at GCSE. You might be given the structure of a different monomer and be asked to draw the polymer. And again, you might be given the structure of the polymer with the repeating unit, the part of it that's inside the brackets, and be asked to draw the monomer from that. So basically you just take the trailing bonds, join them in the middle to remake the double bond. Okay, so let's have a think about one of the issues with using plastics. Plastics are brilliant. They are unreactive, they last a long time, they're strong, they can be molded, so they have lots and lots of really good uses. But there is a problem, and the problem is when we come to throw them away. So they don't biodegrade. So one of their advantages, the fact that they're unreactive or inert, is also a disadvantage when it comes to throwing them away. So they can't be broken down by microorganisms if you throw them away. So how can we get rid of them? Well, there are four options. The first thing is we do just throw them away. Now that's a problem because if they get thrown away, they'll stay in the land for thousands and thousands of years before they get broken down. We could recycle them, and that's a good way of disposing of plastic waste. The issue with recycling is that if you mix up your plastics, then when they get melted down and remolded, the new plastic becomes very brittle. So it is important that before the plastics get remolded, that the different types of plastic get separated. And that's why if you look at plastic objects, you'll often see a recycling symbol with either a number or a letter code to help the recyclers to identify which plastic it is so they can separate the plastic waste, which is obviously time consuming. So recycling is an option. Incinerating is an option. So you could burn that plastic waste to produce energy. That energy could be used to generate electricity or heat, which could be really useful. The trouble is, because the polymers are so large, that incinerating those plastics requires a huge amount of oxygen. Otherwise, you're going to get incomplete combustion and therefore toxic gases and problems with that. So it's a good use of disposing the polymers, but it has to be done very carefully. And then finally, you could reuse your plastic waste. So if you've got a plastic bottle, rather than throwing it away, you could wash it out and reuse it for something else. So consider reusing it. It's by far the cheapest of these four options, and means that you don't end up throwing stuff away. Okay, so that's the end of our study of the alkenes. So in this video, we've looked at the functional group for the alkenes. We've named the first three members of the alkene homologous series and looked at their structures and their isomers, or the isomers of C4H8. And we've considered the reactions of the alkenes, the addition reactions, where alkene molecules either react with halogens very, very quickly, and that can be used as a test for the halogens. And we've also looked at the addition polymerization reactions, where alkene molecules called monomers join together, many of them join together to make one large molecule called a polymer, or an addition polymer. And we've considered the names of these, the uses of these, and some of the issues with disposing of these molecules.